at another example of how to apply the solutions by power series. This is a non-constant coefficient equation. Is second order, so we have second derivative of y, homogeneous, but it's something we cannot solve yet. So let's start up. We have y equals an infinite sequence of a and x to the n. Y prime, we have computed it before, is an infinite sequence of n plus 1, a, n plus 1, x to the n. Y second, we have also computed it before. We have n plus 1 times n plus 2 times a, n plus 1, x to the n. So if we plug these terms directly into our ODE, it fits everywhere. What we want to have is that in our sum, x is always evaluated at the same power. So everything works except the term x squared times y second. So let's look at this term a bit more closely. X squared plus y second would be the infinite sum of n plus 1 times n plus 2 times a at the n plus 2 times x at the power n plus 2. We would like to shift this to have the power of n being, to the power of x being specifically n. So let's do it. We change the dummy variable of our sum to have x at the power n. Is this a problem? Well, we shift everything. We have a sum from n going from -2 to infinity, but the first two elements of the sequence are exactly 0. So we actually have a sum going from n equal to 0 to infinity with n minus 1 times n times a subscript n, x to the n. And now we can plug that in our ODE. So we take all the information that we have about the second derivative of y, x squared, the second derivative of y, minus 2 first derivative of y, and lambda y. We put all of that together, and as we did previously, we take out the coefficient x to the n. So now we have 0 being equal to the infinite sum of x to the n times something that depends on the coefficients. We know that this power series is 0 if every single power is equal to 0. So all the terms between the square brackets need to be equal to 0. We can now write them explicitly, well, write them all along, and we can see again that it's a recursive formula of a n plus 2 equals a fraction with appearing n and lambda times a n. This is the same sort of recursive relation that we had before. If we have this sort of relationship, this defines implicitly y of x. We can physically write the power series. We cannot, but unlike the previous equation, we cannot write it as a closed form. There is no equivalent of the sine and cosine for such odd terms. But this is not a problem. We still have a way to compute y of x. It just takes infinitely many terms.